Hello everyone. In this session you will be learning about designing of standalone off-grid solar PV system. Presented by B. S. Govardhan, Nirvana Foundation, Bangalore. Outline: selection of suitable SPV system capacity, solar panel selection, inverter and battery selection, cables and junction boxes. Design of solar PV system using 1 kW 24 volt inverter, 1 kW 48 volt inverter and 2 kW 48 volt inverter. Solar photovoltaic system or solar power system is one of renewable energy system which uses PV modules to convert sunlight into electricity. Electricity generated can be either stored or used directly or fed back into grid line, combined with one or more other electricity generators. Wide range of applications: residence, industry, agriculture, livestock, etc. PV module converts sunlight into electricity. Solar charge controller. It regulates the voltage and current levels and then supplies it to inverter. Inverter converts DC power output produced by the PV panel into AC power. Battery. Solar batteries are designed for efficient storing of energy and providing power optimally whenever required. Load. Generated electricity is consumed by the loads. Loads are all home electrical appliances. Monitoring systems. Monitoring systems are responsible for controlling the plant operations in order to analyze their operation and performance and to detect and alert about possible errors. Schematic diagram. The output of the panel is connected to the DC disconnect. In a solar PV system, the DC disconnect is placed between the solar panel array and the power inverter. So it can easily be thrown if you need to shut off solar power to the house. Solar charge controller is an electronic device which manages the power going into the battery bank from the solar array. Output is given to battery banks for storage. Energy from the batteries is consumed whenever required and the meter records the consumption. As the loads are AC, inverter is used to convert DC to AC. Backup generators are used if the battery drains out. Solar PV system sizing. Determine power consumption demands. Find out the total power and energy consumption of all loads that need to be supplied by the solar PV system. Mixer, fan, bulbs, TV. Calculate total watt-hours per day for each appliance used. Add the total watt-hours per day which must be delivered divided by 1000 to get kilowatt-hour. Estimation by assuming number of hours and devices. Fluorescent light wattage is 40 watts. And 4 lamps and are used for 6 hours. So the total energy consumed by the light is 0.96 kilowatt-hour. CFL wattage is 18 watts and 2 lamps and are used for 3 hours. So the total energy consumed is 0.108 kilowatt-hour. Fan wattage is 70 watts and 3 are used for 5 hours. So the total energy consumed is 1.05 kilowatt-hour. And the remaining appliances are calculated in the same way. Total maximum connected load is 973 watts. Total energy consumed is 4.687 kilowatt-hour. Energy meter. It is used in domestic and industrial AC circuit for measuring the power consumption. Units consumed will be clearly mentioned in the bill. Here it is 230 units. You can either calculate by recording previous day's reading and subtract it by present day's reading recorded at same time. Monthly average equals to 230 divided by 30 gives 7.66667 units per day. Energy audit. An energy audit is an inspection, survey, and analysis of energy flows for energy conservation in a building, process or system to reduce the amount of energy input into the system without negatively affecting the output. With special equipments and methodology, energy audit is carried where consumption of power is high. Audit activities. In general order. Include. Identify all energy systems. Evaluate the condition of the systems. Analyze the impact of improvements to those systems. Write up an energy audit report. Size of the PV modules. Different size of PV modules will produce different amount of power. To find out the sizing of PV module, the total peak watt produced is needed. The peak watt produced depends on size of the PV module and climate of site location. Consider GHI and DNI, which is different in each site location. Panel generation depends on location, and we that assume standard practices are followed. Daily average direct normal insolation in kilowatt-hour per meter square for some cities in India. Bangalore 5.4. Kolkata 4.99. Hyderabad 5.18. Mumbai 5.94. Chennai 5.23. New Delhi 5.85. Ahmedabad 5.22. Pune 5.12. PV system sizing calculations. Total peak power SPV system is kWh multiplied by 1000 and divided by DNI into ETA. To calculate number of PV panels for the systems is total peak power divided by rated output. Efficiency of PV system is 0.88, our assumption for all our calculations 88%. Direct normal insolation DNI equals 5.4, for Bangalore for our calculation purpose. Inverter sizing. An inverter is used in the system where AC power output is needed. Input rating of the inverter greater than total watt of appliances. Inverter nominal voltage equals battery nominal voltage. For standalone systems, the inverter must be large enough to handle the total amount of watts you will be using at one time. The inverter size should be 25 to 30% bigger than total watts of appliances. In case of appliance type is motor or compressor, then inverter size should be minimum 3 times the capacity of those appliances and must be added to the inverter capacity to handle surge current during starting. For grid tie systems or grid connected systems, the input rating of the inverter should be same as PV array rating to allow for safe and efficient operation. Battery sizing. Recommended battery type deep cycle battery. To find out the size of battery, calculate total kilowatt-hours per day used by appliances. Use the formula shown to calculate the battery AH. DOT is considered between 0.7 to 0.8 for optimum design for all lead-acid battery bank system. Battery efficiency is considered as 88%. Solar PV module selection. Panasonic multi-crystalline photovoltaic module. Model Novi BMS250AE04. Electrical characteristics. Maximum power, Pmax, 250 watts. Maximum power voltage, VMP, 30.2 volts. Maximum power current, IMP, 8.3 amperes. Open circuit voltage, VOC, 37.4 volts. Short circuit current, ISC, 8.86 amperes. Solar battery selection. HBL photo light flooded type lead acid battery. C10 design modular battery. Model, PL150, PL180, PL200. Voltage equals 12 volts. Capacity at 10 hour to 10.5 EBV at 27 degrees Celsius. 150 AH, 180 AH, 200 AH. 4 square mm cables. Connection from solar PV panels to array junction box. Max permissible operating voltage, DCU0/U, 900 by 1500 V. Nominal cross-sectional area of conductor, 4 square mm. Material, fine wire, tinned copper conductor. Core insulation made of electron beam cross-linked copolymer, color of core insulation white. Outer sheath made of electron beam cross-linked copolymer. Outer sheath color, black respectively, black with red or blue stripe. 2. Line, DC wires, MC4 connectors and earth wire. 10 square mm cables. Connection from array junction box to the inverter and battery. Connection from solar PV panels to array junction box. Max permissible operating voltage, DCU 0/U, 900/1500 volts. Nominal cross-sectional area of conductor, 10 square mm. Material, fine wire, tinned copper conductor. Core insulation made of electron beam cross-linked copolymer, color of core insulation, white. Outer sheath made of electron beam cross-linked copolymer. Outer sheath color, black, respectively, black with red or blue stripe. 2. Line, DC wires. Connection from inverter to consumer panel. Current rating, 37 amps casing, 31 amps concealed. Nominal cross-sectional area of conductor, 6 square mm. Material, low-tension copper PVC and XLPE power cables. 2. Line, single-phase wires and earth wire. For single-phase line wire we can choose either red or yellow or blue. For three-phase line 1, 2 and 3 are chosen with red, yellow and blue. For neutral conductor black is chosen. Earth conductor green and yellow. 1 kVA 24 volt solar inverter. Company: NAV Semi-High Max Advance Inverter. Model No. APCU 1024. Electrical characteristics. Nominal battery voltage, VDC, equals 24 volts. PV charge controller rating equals 1 kilowatt peak. Absolute maximum VOC equals 50 volts DC. Maximum charging current equals 40 ampere. For designing any system we have to calculate total demand. Make a table and list out all the appliances and their wattage along with hours of consumption. Calculate the total load by adding wattage of the loads. Here it is 800 watts. Now calculate energy consumed by multiplying wattage of appliances with number hours it is utilized. Add the energy consumed by all the appliances to get total watt hour. Here total energy consumed is 4.7 kWh. Design calculations. Determination of power consumption demands. Total energy consumed by the appliances are calculated by multiplying wattage and quantity and hours of consumption. Solving this we get 4.7 kWh equals to 4.7 units. For sizing of the panel. First we have to calculate peak power of the panel using the formula. Here we got 1 kilowatt peak approximately. And then the number of panels required by using peak power divided by rated output. Here we got 4. So number of panels required to set up a 1 kilowatt plant are 4. Inverter sizing. Previously we have calculated total wattage of connected loads as 800 W. So the size of the inverter must be slightly more than total load. We can select 1 kVA rating inverter with a battery rating of 24 volts. Battery sizing. Battery nominal voltage. As we have selected 24 volts nominal voltage. Total wattage is 4.7 kWh. Depth of discharge of a battery is considered as 0.75. Efficiency of the battery as 0.85. Battery capacity is calculated as shown. It will be around 329.39 Ah. But in market, batteries available rating is 340. So choose 340 Ah battery. Always choose battery of exact size or nearby value available in the market. Battery arrangement. Battery voltage we have chosen 24 volts. Let voltage of each battery be 12 volts. Then the number of batteries to be connected in series to get 24 volts will be total battery voltage by voltage of each battery. Substituting the values and solving it, we get 2. So the number of batteries to be connected in series are 2. Total battery capacity we need is 340 Ah. Let us consider a battery capacity as 180 Ah. Number of batteries to be connected in parallel connection to get required rating is calculated by using formula. Total battery capacity by rated battery capacity. Substituting the values we get 1.88. Rounding off it to 2. Therefore number of batteries connected in parallel are 2. To verify it we can just multiply the number with rated battery capacity. Total number of batteries required are 2 series into 2 parallel equals 4. Therefore 4 batteries are connected in such a way to get battery bank specification of 24 volts 360 Ah. Array designing. First we need to calculate number of panels required for 1 kilowatt plant. By using formula. Total required output by rated output watt peak, which we get choosing the panel. Here we have considered 250 watt panel. Substituting the values in the equation we get 4. Absolute maximum of inverter is 50 volts DC. Open circuit voltage of each panel is 37.4 volts. Therefore 37.4 volts less than 50 volts. One panel is connected in a string. Total number of strings are calculated by total number of panels by number of panels in each string. We get 4. Maximum charging current is 40 amps. Short circuit current of each panel is 8.86 amps. Total current produced by the string is 35.44 amps. As it is less than 40 amps. 4 panels are connected in parallel to the array junction box. We have to select a panel which matches to our calculations. Here we choose Panasonic 250 watts panel. Inverter. NAV semi-high max. 4 batteries 12 volts and 180 Ah. Layout shows 1 kilowatt. 24 volts. Standalone solar PV system. We can see in the left corner. 4 panels output to the inverter through array junction box. Batteries stores the energy and supplies to load whenever required. Designing of 1 kilowatt 48 volt system. NAV semi-high max advance inverter. Model number APCU1048. Electrical characteristics. Nominal battery voltage, VDC, equals 48 volts. PV charge controller rating equals 1 kWp. Absolute maximum equals 90 volts DC. Maximum charging current equals 20 ampere. Load calculations are similar for 24 volt systems and 48 volt system. Detailed calculations are shown. Inverter sizing. Previously we have calculated total wattage of connected loads as 800 W. So the size of the inverter must be slightly more than total load. We can select 1 kVA rating inverter with a battery rating of 48 volts. Battery sizing. Battery nominal voltage. As we have selected 48 volts nominal voltage. Total wattage is 4.7 kWh. Depth of discharge of a battery is considered as 0.75. Efficiency of the battery as 0.85. Battery capacity is calculated as shown. It will be around 153.59 Ah. But in market, batteries available rating is 150 Ah. So choose 150 Ah battery. Always choose battery of exact size or nearby value available in the market. Calculate number of batteries to be connected in series. We get 4. Therefore 4 batteries are connected in such a way to get battery bank specification of 48 volts 150 Ah. Array designing. Number of panels required remains same for 24 volts and 48 volts system. But 2 panels are connected in a string to get maximum of 90 volts DC. 4 panels are required to generate 1 kilowatt power. Number of strings required are 2. 2 strings of series connected modules consisting of 2 modules per string are connected to the array junction box. Layout shows 1 kilowatt. 48 volts. Standalone solar PV system. We can see in the left corner. Two panels are connected in series to form two strings. And the output of the strings are connected to the inverter through array junction box. 4 batteries connected in series stores the energy and supplies to load whenever required. Designing of 2 kVA 48 volt system. Invert. We have selected NAV semi. Battery voltage is 48 volts. Controller rating is 2 kWp. VOC is 90 volts. Charging current is 40 amps. Load calculations. Total wattage of the systems is 1500 watts. Energy consumed is 8200 watt-hour. Load calculations. Total wattage of the systems is 1500 watts. Energy consumed is 8200 watt-hour. Detailed calculations of energy consumption is shown. Size of the PV panel. Peak power of panel required is 2 kW peak. Number of the solar panels required are 8. Inverter sizing. Connected load is 1500 watts, non-inductive. The inverter size should be equal or slightly more than the load. That means 2 kVA single-phase system is more suitable, which has a battery bank voltage will be nominally 48 volts. Battery sizing. Considered battery nominal voltage is 48 volts. DOD as 0.75. Efficiency of battery as 0.85. So we can substitute in the formula to get battery capacity 300 Ah. Number of batteries to be connected in series are 4. Number of batteries to be connected in parallel are 2. So total number of batteries required are 8. These must be connected in such a way that we get battery output as 48 volts and 300 Ah. Array design. Total number of panels required to generate 2 kW are 8. As VOC of inverter is 90 volts. To achieve this, 2 panels must be connected in series. As panel voltage we get 74.8 volts is less than inverter voltage. 2 panels must be connected in one string. Number of strings required are 4. Each panel generates 8.86 amps of current but required is 40 amps. So 4 strings of series connected modules consisting of 2 modules per string are connected to the array junction box. Electrical characteristics. Total 8 modules of Panasonic 250 watt panel are required. 8 batteries and an inverter of 2 kW. 48 volt is chosen. Layout shows line diagram of 2 kW. 48 volts. Standalone solar PV system. We can see in the left corner 4 strings in which each string consists of 2 panels connected in series. And the output of the strings are connected to the inverter through array junction box. 8 batteries connected to get 48 volts output. We are also providing training on solar PV design using PVSYST software. Entrepreneurship opportunities in solar energy. How to draw single line diagrams of PV systems using CAD software. At our institute. Nirvana Foundations. Bangalore. Thank you. For any queries, visit our website www.nirvanafoundation.com.